Okay, everybody, welcome back. I want to today kind of finish up our discussion about aquatic biomes. In the previous video, we talked a little bit about some of the freshwater biomes, things like rivers and streams and lakes and wetlands. Make sure we review those notes and make sure we understand some of those conditions for those things to exist. And today, I want to just finish this up with the other type of aquatic biome, which is a marine biome. So again, yesterday we talked about all the biomes on the left. Today we're going to talk about these five just briefly. I'm not going to go super in depth into each one of these, but just give you kind of a general description of what each one is. All right, so we'll start with something called a salt marsh. All right, salt marshes typically appear near the coast. We see a lot of salt marshes on the eastern coast of the United States, actually. Here, for example, this area in green over here, this is actually the state of Virginia, which is on the eastern coast of the U.S. And here's a river here. It's called the James River. The James River carries fresh water and it drains out into the Atlantic Ocean, where you obviously have salt water. So anytime you get fresh water, like that's in the James River, and you get salt water and they kind of meet like head on, that's what we typically call an estuary. An estuary is kind of a mix of salt water and fresh water. So, like here in the James River, all these areas that are kind of in pink, these are all salt marsh areas because I mean, just like a regular marsh, and we talked about yesterday, there's a lot of that non-woody vegetation. The difference is here we have water that has a much higher salt content, all because it's in an area where the salt and the fresh water are mixing. So we get an interesting diversity of living things that can live in these areas because some things are a little bit more tolerant to salt, some are a little bit more tolerant to fresh water. But this is kind of a nice mix where a lot of things can kind of survive because it's not too salty and it's not too fresh. It's kind of a mixture of both. But again, marshes, just like we talked about yesterday, are still, they're home to plant life, they're home to animal life. There's a lot of breeding grounds for fish and for birds. It acts as sort of a filtration system for fresh water. So some of the same, importances of marshes that we talked about yesterday. Just make sure you know that a salt marsh is typically found near an estuary where salt and fresh water mix. That's kind of a big thing. A mangrove swamp. Mangroves are really kind of cool. I actually had a chance several times in my life to go down to the Florida Keys. This is one place where you're going to find these things at. Um, and I actually did a lot of snorkeling in some mangroves. And it's really kind of just an interesting habitat. You don't see anything like this anywhere else in the world. Um, One big hallmark of a mangrove swamp is there are trees called mangroves. Mangrove trees are one of the few trees in the world that can actually live in salt water. These are called halophiles. Halophiles are basically a plant that can survive in salt or salt water. And there's not very many trees that can do that. Mangroves are one of the very few. The thing is, since they do so well here, they tend to dominate the area. If you go down to the southern tip of Florida, down here in Miami and the southern coast and the Florida Keys, you're going to see these plants growing everywhere. Especially near the coastline because that's kind of where they dominate and they actually live. They grow in the water and they just emerge up through. And you'll see all these. These are all the roots of the mangroves. The roots actually kind of embed themselves at the bottom, but then they actually grow through the surface. That's a really important place for fish to breed A lot of juvenile fish will swim in there, hide from predators, things like that. So it's really important for them. It's also kind of an interesting, or has a real interesting impact on the rest of the inland shore. Down here, you guys might know this. I mean, this is like, Hurricane Alley down here. A lot of hurricanes hit this area. So if there's ever any big storms or big wave action that comes in, a lot of these mangrove trees will kind of block a lot of that wave activity and protect, what's inland, which might be a lot of people's homes or, that's where people live, right? So it actually acts as a really good barrier or a defense against a storm surge. They're really important for that. The intertidal zone. The intertidal zone is kind of exactly what it says it is. It's an area, um, that is impacted by the tides. Let's say, for example, in this picture here, kind of this like slope of, um, I don't know, rock or shoreline, whatever this is. And you see all these organisms that are kind of attached to it. That's again kind of a characteristic of an intertidal zone. You'll have a lot of organisms that have to permanently attach themselves to a substrate like rock or something. You see a lot of things like oysters and barnacles and um, starfish. A lot of things that can kind of suck on or attach themselves. Because I want you to think about this. I mean, if this is a tide zone, that water's going to come in, it's going to rise up, stay there for several hours, and then it's going to go back, right? It's going to expose everything, to the wind and, rain and whatever. So these are organisms that are really under a lot of stress all the time because that environment is not very stable. I mean, it's constantly, changing. So we see a lot of organisms like that in the intertidal zone. And obviously, it would be like near the shore, but again, it would only exist when there's those tides that come in and go out. So intertidal zone is kind of understandable. Here's a good picture of the intertidal zone. Obviously, look at the wave action here. It'd be probably really difficult for a lot of fish to live in here. But organisms that can attach themselves permanently to a rock or something probably would do very well. So that's why we see a lot of those things living in those areas. Here's a lot of little oysters or mussels or something that are living on these rocks. What we're kind of seeing in this picture is most likely the low tide, right? And then when the high tide comes in, this whole thing would be underwater. So again, there's constant, exposure, and then being covered in water. So it's kind of a volatile environment for these organisms. Coral reefs, I've talked briefly about these this year. Coral reefs are found in typically very warm waters and typically very shallow. The conditions for a coral reef to exist are very delicate. I think I talked earlier in the year about, if the water temperature changes, just maybe a degree or two, that has a huge impact on the coral reef. And that can make the difference between, seeing a scene like this with all the pretty colors and, the fish and the sea turtles and all this versus like a totally bleached out, coral reef and, no living things around it. It's like a dead reef. So these are very delicate. They're extremely diverse ecosystems. Some of the I almost think of them as kind of like the tropical rainforests of the water. I mean, there's just a ton of diversity here, but they are really being threatened by climate change, big time. The open ocean, just a quick, kind of dissection here, kind of an anatomy of the ocean. In the background here, you'll notice the term intertidal zone, right? So here's like the shoreline. Again, the high tide, the low tide really would affect that intertidal zone. Here we have, again, the benthic. You guys might remember that when we talked about lakes, right? The benthic is the bottom. Now, how deep the benthic is kind of depends on where you are, right? Sometimes the benthic zone is only maybe 30, 40 feet deep. Sometimes it's, 500, 600 feet deep, depending on where you are. Then we have what we call the photic and the aphotic. Photic, again, that's where light can penetrate through, kind of like the limnetic zone of a lake. And then we have aphotic, which means no light. When you get out into the open ocean, the aphotic zone can be very expansive. Okay, I mean, because the ocean can be a heck of a lot deeper than, let's say, a lake or a pond would be. So just kind of know photic and aphotic. That should make some sense to you, I hope. Our last couple things here, real quick, which I think are kind of important. Move myself over here. This map is showing us something called sea surface salinity. So just by looking at the map of the planet, we can kind of see that the salinity, the salt content in the ocean varies. And it's never really stagnant. It fluctuates and changes all the time. So, for example, what we're looking at here, these areas in orange, for example, those are areas of pretty high salt content in the ocean. These areas in blue are areas where it's a little bit less. But those things can change. They can shift. So really, I mean, the ocean is a dynamic place. It's constantly moving and flowing, and the amount of salinity kind of varies depending on where you are at a certain time. So understand that salinity can vary. How much salt there is in certain places definitely changes from day to day, minute to minute. Um, Depth of the ocean. Yeah, I think we kind of understand this, right? I mean, these areas that are a little bit darker, those are areas that are much, much deeper. These areas that are a little bit lighter, like the light blues, those are areas that are a lot shallower. So again, not only does salinity change, but just the depth of the ocean, how much, how deep it is and how shallow it is, that varies from place to place. Temperature of the ocean changes. Not only does it change by depth, as you go down, it gets a lot cooler. We call this the thermocline, right? So as you're getting deeper and deeper and deeper, it gets much, much colder. The closer you are to the surface, it tends to get a lot warmer. But even that surface temperature, that can change with the current. If the current is flowing in a certain direction, that current could be carrying colder water. So we can get surface temperatures that vary from cold to warm depending on the day, depending on the month. All right, so that again, this is another real volatile thing. It goes up and down all the time. Temperature is not something that stays fixed. It definitely varies all the time. Turbidity. Turbidity is, like visibility. Like for example, this picture on the left over here, you're seeing, let's say, for example, 100% visibility. Um, when the water is not very turbid, it allows sunlight to penetrate down pretty far. If there are things suspended in the water, like dirt particles or pollutants or whatever it might be, garbage, who knows, then the visibility is a lot less because the water is a lot more turbid. So that has a big impact on oceans as well. In different places, the water is either more or less turbid. Nutrient availability. So again, I mean, nutrients are important for fish and for other organisms to feed, but a lot of times the nutrients are at the bottom of the ocean. But because the ocean is moving and currents are flowing, a lot of times those nutrients will come up to the surface. We call that an upwelling. Fish love that, right? Because most of the fish are up here at the surface. So when there's an upwelling, all of those organisms from the bottom, all of those nutrients come up to the surface, and that's how the fish can feed. So upwellings, again, the nutrient availability changes as the ocean is changing. And really, all of this is important because, what's in the ocean? I mean, there are resources that we use. Right? Let's think about fish, for example. If you're a fisherman, you have to find the fish. And fish depend on salinity, they depend on temperature, they depend on food, all these things that we just talked about. So as the ocean is changing, as it's dynamic, then the fish are moving as well. So I mean, this global distribution of all of our fish depends on where all those ocean conditions or what all those ocean conditions are doing. If, for example, the ocean is becoming a lot saltier, then that's going to impact fish. If the depth of the ocean is changing, because ocean levels are rising, that could impact fish. Turbidity, how murky the water is, that could impact fish. Are they going to be able to find food, nutrient? I mean, all these things impact these resources that are so vital that we get from the ocean. All right, so make sure we understand that. Those are really important things. All right, we'll stop here for today, guys. Thanks for staying with me on this. And that'll conclude our 2 videos on aquatic biomes.